So let's do example number 4. So I see this thing. So what that it's an 11? They are 2 powers. When you have 2 powers that you are multiplying, we always keep the base. That's important. But we're multiplying these 2 things. What should we be doing to the exponents? Adding. You have to know that, okay? It's on your card, but you should also know it. You are adding the exponents. Let your calculator do the work. -1/2 plus 5/2. What did it give you? 2? There you go. Now, let's be honest. Should you be able to do 11 squared in your calculator? Yeah, what is 11 squared? It's even on your card. Yeah, I'd probably go on and continue this on to give you 121. All right, if I want you to go further, or if you're not sure, it's quiz test time, just ask. I will tell you how far to go. I would say 121 is your best answer right here, because you know you can do x squared pretty easily. All right, but then we get to the next one. And just like before, ooh, don't know what that one's doing. Just like before, when you see a number or a letter that does not have an exponent, what should you do? Yes, you need to include that 1. Stop fighting it and trust me that it will help. Now, again, like before, you have a couple of options here. You are welcome to deal with the 2 on the outside first, or you are welcome to deal with simplifying inside the parentheses first. It does not matter to me which choice you make. You just have to make a choice. What would we like to do first? The 2 on the outside or simplify inside? Bueller. Come on, somebody pick one. What do you want to do first?
Inside.
Thank you. I like that. That is a good choice. Guess what? If you would have said outside, I'd have said good choice. Everyone pay attention to this. If we are going to deal with the inside first, you are dividing 2 powers that have the same base. What are you going to do to those 2 exponents? Thank you. You have to know it's subtract. No one else can tell it to you for you at this point. We've been doing this too long now. You have to recognize a subdivision problem as subtraction of the exponents. In your calculator, everybody, 1 minus 2/3. And if it gives you a decimal, math, enter, enter. What did you get? All right. Now, you still have outside a square. What are you going to do to the exponents on that? You're going to multiply them. Now, again, I'm not testing your ability to multiply 2 1/3. So please, trust the calculator to multiply 2 1/3, because I know what some of you are going to do. You're going to multiply 2 to the top and bottom of that and get 2/6. That is not the answer. Your answer should be 10 2/3. Because when you are multiplying fractions, FYI, this is a side note, anything that's not a fraction can be turned into a fraction, and then you multiply numerators and just denominators. Okay? Guess what? That's your answer. You're done. All right, I'm going to skip 6. So now, number 8, you've got x to the 1/2 times x to the 3rd over x to the 5/4. What part of this problem should we do first? Yeah. Now, the 2 things are being multiplied. You have 2 powers with the same base being multiplied. What should you do to those exponents? Add them. Put in your calculator 1/2 plus 3. What do you get? 3/2? That's not 3/2. What should it be? 7/2. Again, don't want to know whether you can add or subtract fractions. I know that sounds awful, but I want you to know that you are adding them and let your calculator do the addition part. I'm quizzing you on whether you know the properties of exponents. So now you've got x to the 5/4 on the bottom. So we have 2 powers that are being divided. They have the same base. What should you be doing to the exponents? Subtracting. And it must be top exponent minus the bottom exponent. And when you put 7/2 minus 5/4 in your calculator, What does it tell you? Negative 1/4? 9/4. I'm sorry, I heard a negative. So 9/4. Man, we haven't got a negative one to deal with yet. Are you done? Yes, you are done. And just because I want to record it, just because it's a good thing to record, if I ask you to rewrite this in radical form, this again is just reviewing from yesterday. If I want you to rewrite this in radical form, x stays as the radicand. Who's the index? 4. Where can I put the 9? Yep, I can put it in the inside or on the outside. Again, that's just a sidebar. All right, one last one. So, number 9, I've got x to the 5/6 raised to the power of negative 3. So you have a power being raised to another exponent. What are you doing to the exponents? Thank you. You need to know that. Again, not testing your multiplication skills. Put it in your calculator. What is 5/6 times a negative 3? All right. Now, if you have negative 5/2, is this problem done? No. No negative exponents in your final answer, which means you are going to turn this into a fraction by putting it over 1. If you have something with a negative exponent, it must change its location from numerator to denominator or denominator to numerator. This part right now is in the numerator. So take his little self and move him to the bottom. What's left in the numerator, though? 1. The whole point of you moving him is so that the exponent becomes a positive exponent. If you don't change the sign of the exponent, then you kind of wasted your time. These two things are equivalent. And this problem is done. All right. Uh-oh. Take a look at the next problem. Let's do some solving, which means you are going to tell me a value for x, and yes, I'm going to let you use your calculators on this. Aren't you excited? I don't hear excitement. Terrible excitement. Okay. I've now thrown in an equal sign in here. We are going to use these exponents to help us figure out what is x, that when you cube it and then take the 4th root of it, you get 125. Now, I'm going to employ our rules from the last class. Radicals can be rewritten as rational exponents. When you are solving these types of problems, it really is much easier to solve, especially using a calculator, if we change this first. So let's rewrite this. We can say this is x raised to what power? 3/4. Yep. So the index becomes the denominator. The exponent becomes the numerator. If there's no exponent, assume it to be 1. Now, the goal is to get x by itself. I have to undo raising to the power of 3/4. This is a new concept for you. So to undo addition, we subtract. To undo multiplication, we divide. We need to undo to the 3/4 power. Here's how it works. You are going to actually take both sides, and you're going to raise both sides to a new power. And that new power is going to be the power that when you multiply it by 3/4, it equals 1. What can I multiply to 3/4 so that I get 1? Well, if I multiply by 0, what do you get? 0. Well, 3/4 times 3/4, put it in your calculator.
Isn't it the reciprocal?
That was the most beautiful word I've ever heard. Yes. Yes. If you use a number's reciprocal and test it out, put it in your calculator. Take 3/4, multiply it by 4/3. What do you get? 1. A number times its reciprocal is 1. So you have to know reciprocals. And what we're going to do is we're going to take that fractional exponent, we're going to raise both sides to the reciprocal power. What we do to one side of an equation, we do to the other. That's how we keep the equation balanced. Now, you already know a power raised to another power, you multiply the exponents. And you also now already know that if you multiply a number and it's reciprocal, what's going to happen to this guy right here? What's he going to become? 1. Awesome. Do we need to write it? Nope. Because our goal was to get x by itself. X to the first power is by himself. Now, I know you can do this without a calculator because you did that in the last homework assignment for me. But today I'm going to let you use your calculator. So now, in your calculator, you are going to put 125 raised to the 4/3 power. But be careful. In your calculator, you must use parentheses around the fractional exponent. If you don't use parentheses around the fractional exponent, your calculator will not calculate in the correct order. So 125 raised to the parentheses, or raised to the power of parentheses 4/3. What did your calculator tell you? 625? Happy bubble cloud of joy. There's your answer. Lot going on there. Shall we try again? Yes, we shall. Let's try another one. So 2x raised to the 2/5 power equals 16. Awesome blossom. All right. Do you have to rewrite this one, or is it good right now? It's good. You want the fractional exponents, so you want rational exponents. Goal is to get x by itself. X is being raised to the power of 2/5. Because it's a fractional exponent, we have to raise both sides to a power. What's the power we're going to choose? 5/2. We're going to choose the reciprocal power. My pen does not want to write there. It must be the reciprocal. And it's the reciprocal because now this power to this power, when they multiply together, will give you what value? 1. Now, let your calculator do the work. 16 raised to the power of parentheses 5/2. What did it tell you? 1024? Awesome. Look, smiles, happiness. Math makes us feel warm and fuzzy. Yeah. All right, one more. All right. So far, questions though. Let me do a last one. I've added a little twist because you know I like to add little twists. And the little twist is I've put something inside with the x. He's just going to add an extra step onto our problem. Because the whole group is inside a set of parentheses, we're not going to touch that 15 until after we get rid of the 3/2. If the 15 was outside the set of parentheses, then we would do something with him first. But we've got this guy here. The goal is to get rid of him. So because he's an exponent that's a fraction, I'm going to raise both sides of this problem to what? 2/3. We're going to use that reciprocal power. We're using our powers of math for good, not evil. No? Okay. Seriously, you guys are the toughest crowd I've got. It's all right. Now, we do this again because what's going to happen to the 2/3 and the 3/2? When you multiply those together, what should you get? 1. Which means, goodbye. You do not need to deal with it. You're left with x plus 15. What should we be doing with this 64 to the 2/3? Una calculadora? Click, click, boom. Now, you should be able to do 64 to the 2/3 without much ado, because you did this the other day with me without a calculator, just your card, but I'm letting you use your calculator for these ones that are equations. So 64 raised to the 2/3 power is what? 16. Fabulous, but are we done? No. Oops, sorry. I just need to erase. I put 16 there. 15 equals 16. What's the last thing you have to do to make this problem solved? Yeah, subtract that 15. It's being added to x. Our goal is to get x by itself. So we add the opposite. That cancels out, and you're left with 1. Man, all that work, and the answer is 1.